Hi everyone. In today's challenge, we have a problem. The problem name is Implement Trie, Prefix Tree, and the problem number is 208. Alright, guys. So first of all, we are going to clearly understand what this problem says. After that, we are going to move to the logic part. We are going to see how we can solve this particular problem. And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, and Python programming language. Fine. Now let's see what this problem says. Right. So problem says a trie, pronounced as a trie, to or prefix tree is a tree data structure used to efficiently store and retrieve keys in a dataset of string. So this is basically a definition of trie, right? What is trie? There are various applications of this data structure such as autocomplete and spell checkers. Fine. So now guys, it says that what is a trie? Trie is a data structures. Alright, it is also data structures like we have a stack, queue, tree, graph, right? But this trie is a data structure which is somehow related to tree. Right, first thing keep in mind this thing. And what this is what is the specialty of it, right? As we have a specialty of stack is last in first out, queue is first in, we can say first in first out, right? So what is the specialty of trie specialty is that it use we can say a prefix type kind of binary, or we can say tree, right? So if you have a word, so let's say, let me understand this in a deeper. So if you have a word computer, right, and you want to store this word as well as many other words, and you want to get a word, we can say by the prefix names. If you want to say check whether comp is present in my dictionary or not, in my collection of words or not, so there try will come in a picture, right? If you still don't have an idea, then let me tell you a basic example. So if you, let's say you are writing comp, right, and you want to get a suggestion, so what it will do, it will give you suggestion computer, it will give suggestion compute, it may give you a suggestion comparator. So these suggestions are coming just because we know that there are actually word starting with this particular character. So how you can make this kind of things in this kind of software, that by using this particular trie data structures. Now let's see how we can implement this, and you will definitely get a better idea if you still don't have an idea by just these four function or four methods. So first method is trie, which can say the constructor. Second is insert. If you want to insert some words in your dictionary, if you want to update your dictionary, if you want to insert any new words which just now released. And boolean search, let me check whether particular exact word exists in our dictionary, or we can say our collection of words. Start with says that whether any, we can say our word, let's say, again take the same example computer. Let's say if we want to check whether this compute is present in our dictionary or not actually, but this word is somehow present in the prefix of any word or not. So this compute, you can say the present in a computer prefix, right? You can see that. So we are going to return true. So this is how such we can say start with method function work. So this four function we are going to implement it, and this is a problem actually. If you understood the problem, definitely well and good. If you did not, then let's see the logic part, and there also you may understood this particular problem, right? So example one, you can see, if you understand example one, then you can see that first of all we call a constructor, right? You can see in the out explanation we call a constructor. Then we inserted apple word. So in our collection we have a apple now. Fine. Then we insert search for apple. Then you can see that collection we have apple, right? So it's gonna return true. You can see return true. Then we search app. Does app exit in our word? Collection of words? No, app is not exit. Yeah, prefix of app exit in a prefix of some words, but actually app word is not exit, right? But search function is used for find the actual word. So it's gonna return false. Then we are saying that starts with. That start with app exist. Does app come in prefix of any words? Yes. You can see in apple we can see the app is coming, right? So we can say return true. And insert new word app. Fine. Now we have not apple, we have app as well. Now we are going to search it. Does app exist? Yes, actually app exist now. So we are going to return true. So this is the example, guys. I hope you understood this, right? So this is a basic example. If you understood the previous part, like problem understanding, then you will definitely understand this example. Now let's see the logic part. We don't want to see that. We now want to see that how we can solve this particular problem, right? What is the data structures? So what I can say, so guys, just understood about in a tree. As they have told you, I haven't take out that picture, but they have told you that this only contain 26 lowercase character, English lowercase character, right? Fine. Now guys, what I can say, this is first node, which I could say the starting of my, we can say, a character, right? So first node, which is gonna be the starting of my try node, and this gonna contain we can say 26, or we can say dictionary. If you understood about hash map, if you know Python, then dictionary. If you know Java, then hash map. If you know Python, then an order map or map, right? So what we can say that it's gonna have some dictionary, right? There's some kind of map, some kind of dictionary. Fine. And if we want to insert a first, if we take a first example only, if we want to insert apple, so how we gonna insert apple? So you can see that if we want to insert apple, then first of all this node, if I assuming this particular node, the starting node will say that okay, it gonna traverse over this particular thing. Fine. Does A exist in our binary? Oh, sorry, A exist in our tree? No, you can see dictionary is empty, right? So what it's gonna do in this thing, it's gonna create an A, all right, and it is gonna say A exists. Now for me A exists, and the node of that is nothing but this one. Fine. So now A exists, right? Now we come to here. Now we are here actually. The focus over here. I know in the first time you will not get it completely, but definitely first time you will get a 50 or 75% of this. But definitely, if you will watch carefully this particular part, this is the main part, then you may understood the full logic part, and you may get the clear understanding like how to implement this particular tree, right? So A we come to here. We implemented A. Now again I move to the P. Does P exist? So now you can see that P also not exist in this thing. In this thing P does not exist. So this is nothing but we can say A. So I have write A here. I am going to say P because P was not exist. So I made a P. Fine. Similarly, I will make it apple. Let me make it apple. So I'm gonna do again and again. So I'm gonna say again. Here also it will come A, then P, then P. Then again I'm gonna do not this color. Okay, and the last one, right? Fine. So this is gonna be E. Alright, so if you focus over here, guys, you can see A was not exist, we created a A node for it, right? P was not exist, we created a P node. Again, P was not exist in these things, we created a P node. Again, L was not exist, we created L node. Again, E was not exist, we created a E node. Fine. So this thing is gonna contain our trie. There is a node, and this node, what the functionality this node will have? A single node will contain nothing what we could say. The first thing is we can say a dictionary or a hash map, dictionary or map. Second thing is contain does end of word, right? This two thing is contained, and this is going to be nothing but boolean, and this is going to be nothing but a dictionary hash map, right? Fine. Now you will understand definitely once. Now we are going to move to the second word, that is nothing but going to be app. And not app, yes, it is app, right? So we're going to now insert app. Now you can see how it's going to help it. Now guys, if you will focus over here, so we are going to insert nothing but app, right? Or we can try dry run. Before inserting we can dry run. It's called a function insert. We have inserted it, and we have make it the last one is nothing but this one. So we have make it this is end of word, right? So this we can say this is a functionality of end of word. This is going to be nothing but true, right? If one here end of word is not true, right? And here end of word is not true, everywhere false. So I can write inside of this false, 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 false. But here end of word is true because we are reached to the end of the word, right, while inserting it. So we are going to make the last word as a true, right? So last node as a true, right? Now guys, its second function is search, right? So we are going to search it. Whether we are going to search now, what we are going to search, we are going to search apple, right? So let me write a apple. So I'm going to search apple. So I'm going to start again from my root. I'm going to say a exit. Yes, you can see that a exit, right? Now a exit, we're going to move to this one. Does P exit? Yes, move to this one. P exit? Yes, move to this node. Yes, L exit? Yes, move to this node. Does E exit? Yes, move to this node. Now we are end of the system. Now we are going to check it whether the node here we have reached now is having an end of word true. Yes, you can see it is a true, right? So we are going to return true. I hope this makes sense, right? So you can see in the output as well, we have nothing but true, right? So you can see true. Now we are going to search app. Now you can focus here. Now we are not going to search apple. We are going to search app. So focus over here. Does A exist? Yes. Does P exist? Yes. Does P exist? Yes. Now we are end of the string, right? So we're going to check it. This node has end of word true. No, it is false. So we are going to return false. All right. Now we are going to insert app, right? Now we are going to check it. Starts with first of all now starts with app. There is one more method that is start with. So here what we are going to do, we are going to our same thing. A exit yes, P exit yes, P exit yes. So we are going to return true. If we reach to the end of this word, then we are going to return true. But if it is a case A, P, T, then we are going to check first of all A exit yes, P exit yes, T exit no. After this node we don't have T, so it's going to return false. So we can't reach to the end of this string. We are going to return false. I hope this makes sense, right? Now there's a next function that is insert again. So we're going to insert app. Now focus here. We are going to insert second word that is app. Now here you will find out the benefit of this trie. So now we don't need to make a again node of A because you can see we are going to start with root node. Does A exist? This A already exists. We don't need to make we can say new node of A. Okay, we come to this. Does P exist? Yes, we come to this. Does P again exist? Yes, already exists. So we don't need to create any more node. We can say we reach to the end of the string. So we are going to make this particular node as a true. I hope this makes sense, right? We are going to make this particular node as a true. So we are going to make it true. Now, if we are going to move to the next function, that is nothing but let's see what is the next function. So that is next function is search. Now we are going to search app. See guys, search means we need to find a completely word, right? So once we're going to search app, A exit, P exit, P exit, now we reach to the end of string. Does this contain true? Yes, it contain true, so return true, right? So now I'm going to insert one more word if to make you clear understanding. That is nothing but we can say 8, right? So 8 word we are going to check it. A exit, yes, A exit. Okay, does T exist? No, T does not exist on this node, right? There is only P exit, right? So we're going to create one more node, and here what we're going to do, we're going to create a T. All right, so it's going to be nothing but we can say T. Now fine, now we come to this particular node and it is fast right now, right? Now E exists. No, E also not exist on this node. You can see E is not exist. So what you can do, we're going to say create one more node with this and make it E, right? All right, so it is a E, and let me write a E. And is it as now we reach to the end of the string, so it's going to be nothing but true, right? So now you can see that if we want to now starts with 8, then also it's going to return true because you can A to T. But we are not making a same node, right? We're not again creating a A node, right? Because it already exists there. We're not again creating a PP node because they are already exist. So this is the benefit of try. Now guys, I hope you understood this. Now let's move to the implementation part, see how we can implement this thing, right? So let's move to the implementation parts, and here first of all I'm in the Python. So first of all I will do with the Python, then I will do with the C++, then Java, right? And I am going to use a hash map, or I can use an array. So first of all Python I'm going to use a hash map. So I'm going to create first of a class of my try node. It's going to be try node, and this class is going to contain let's say constructor that is nothing but init, fine, and it's going to say self. And here I'm going to make self first of all a children, right? Children is nothing but how many there is only at max 26 character, right? You can see in the constraint there is clearly written that word and prefix consist only of lowercase English letter. So we can say children is going to be nothing but let's take a dictionary here, but you can take array of 26 size as well, right? So I created a dictionary, and I'm going to say one more thing, that is end of word, right? Or I can say this like this, end of word. Initially it will be fast. I hope this makes sense. Now we are at a constructor. So what I can say, self.root is gonna be equal to try node. Fine. So I created a we can say the node first. Once this class we call try. Now we're gonna insert some word. So how we can do? So first of all, I'm gonna say current is gonna be my root. And now guys, focus over here. We are gonna traverse over word as I have already told you for ch in word, and we are gonna check it if this current dot child and children, right? Children is contain. If current dot children contain our this particular character, if ch in current dot children, then well and good. We don't need to do anything, right? But if it does not contain, then what we are going to do? We are going to create it. I hope it makes sense. So we're going to say current is going to be equal to what we are going to do? We are going to say create a new node with this particular character. So current dot children of this particular character should be equal to try node. Fine. Once we create it, we are going to move it current is equal to, I can say current dot children of that particular character. So once we come out from this loop, that means we have inserted all the characters. Some character may be already present, some character may not be present, right? We have once we reach to the end of the character, we are going to make it. You can say current dot end of word is true. You can say this is the end of word, right? Not true, capital TRU, right? All right. So and here is also capital FARC because this is a Python. Fine. Now once we are done this thing, we have completed for insert, and same code you can see that I'm just going to copy it because I don't want to make it again and again. What I'm going to do, I'm going to just say that if for searching bar, just check it, traverse over the word and check it. If word exit, then move to that particular. But if word is not exit, then directly return false, right? If word is not exit in that particular children, so return false. And if I want to make you clear understanding, so let me take you here in my notebook. Then you can see if I'm searching for let's say banana, right? So you can see initially b does not exist on this node, right? There's only a node exists, so we are going to return directly false. And if I want to search a, and let's say some other words, we can say if I want to take auto, right? Auto complete, or we can say automation, right? So a exit, but after that we need u. But here in this node you can see that p and t exit, but u does not exist, so we are going to directly return false. All right, so we are here and we are going to return directly false. Okay, so I'm here returning false now, but if it's exit, so move to there. And at the end you have to, what you have to do, you have to return the current or dot end of word. Once you completed the string, then check it whether that is the last that node contain end of the word or not. If that node contain end of the word true, that means this is the last word, we can say, right? So definitely this word is totally exit in their collection of words, or we can do dictionary. So because now this is a, we can say search method, but there is a method of starts with. So for that method, what I'm gonna do, I'm going to copy paste, simple. And here I'm going to check it, return true. Why it is I'm going to return true? Because I don't need to check it whether that particular word completely ending or not. If that particular word is coming in between of in the prefix of any of the word, return true directly, right? So we are going to run this code and see whether not here I have to use, here I have to use a prefix, right? Before running that I have to use a prefix. Now let's see whether running. whether it's completely having any error or not. And yeah, we got an error, that is root, right? What is a root? Actually it is self.root, right? And here again I need to write self.root, and here also I need to write self.root. Let's see whether we have any more error or not. And I believe I should not get any error, and you can see that it got accepted, right? So let's try to submit this code, and let's see. Yeah, you can see that, guys, it successfully submitted, right? So now let's move to the another programming language, that is nothing but we can say C++. And here what I'm going to do, I'm going to create again new class, that is mandatory, right? Because we want to, you can create inside of structure as well, but I'm going to create I'm going to comfortable with the class. So I created a class try node, and here what I'm going to do, I'm going to say public, and here I'm going to make a map first of all, an order map int, and this not int, I'm going to say directly is the characters. And you can create an array as well, but okay, but I'm going to go with the map. And here I'm going to say try node, fine, and not tree node, try node, fine. So this is the name, I'm going to give it the dictionary, fine. And once after that I'm going to create a boolean value, that is nothing but bool, let's say end of word, fine. And I'm going to say the constructor try node, and in this constructor I'm going to say just this end of word should be equal to false. Fine. Now we are done with this. Now this is not ch. This should be char. Okay. Fine. Now what I'm going to do, I'm going to create inside of try class a root. So I'm going to say try node root should be equal to new try node. All right. Now in try constructor, I'm going to say okay. I can initialize here as well, right? It's not a big deal. I can do this thing here as well, so it will not going to give error. But all right, so fine. Now we are going to insert this particular word in our try. So how we can insert it? First of all, we are going to say current, right? So we can say try node, we can say current should be equal to our root, fine. And we are going to traverse over this, so we can say for int I0 I less than word dot length and I plus plus, and we can say character is going to be nothing but char ch is going to be nothing word of I. Once this is done, once we got a word of I, what we can say, we can check it in our map. So we can say if this our dictionary dot find not children, I have given a name dictionary, so dictionary dot find ch, and dictionary of what, our current, right? Current of dictionary dot find ch is equal to current of dictionary dot end. If it is equal to end, that means that particular character is not exist in our dictionary. That means we don't have a node for that particular character, right? So for that particular node we don't have a further node, right? So what we are going to do, we are going to create a new node with that node. So we're going to say let's create a new node. So current of dictionary of that particular character, create a new node, that is going to be nothing but try node, right? We have created a node, and now we are going to move to that particular node, current dictionary of that particular character. Now once this is done, we are going to make it end of word true, right? So we can say current of end of words, we're going to make it true. So this is for the insert function. Let's see whether we have done any error. So first of all, we created a current, which is pointed to a root. Then what we have done, we have done with traversing over words, and we are going to say therefore that particular words, check whether that particular node exists. If node exists, so create it. Otherwise, move ahead with that particular character. Alright. So once this is done, so we are going to copy same thing, and we are going to insert pasting our search word, because they're totally same. We don't need to do anything. We are just going to return here current end of words. And what we are going to do, we are going to say if word does not exist, directly return false. Don't need to do anything else, right? Because we are totally want to get that particular word, right? So return directly false. Fine. And here in start with also I'm going to totally paste it, but here I have to change something. I have to change word to prefix, and here also word to prefix. And here I'm going to say if does word does not exist, directly return false, because we want that should be in prefix, right? So return false. All right. And here just return true. It should not be the mandatory that it should be end of word, because we want a prefix also, right? So return true. Let's try to run this code and see whether we are having any error or no. And let's see. And you can see that it totally get accepted, right? So let's try to submit this code, and it was easy one with C++, right? And here we go, guys, right? It's successfully submitted. Now let's move to the last programming language, that in nothing but we could say Java. And in Java, what we are going to do, first of all, we are going to use an array. And why? Because I want to tell you that we can use also array. It's not like definitely you have to use a hash map for dictionary, right? So I'm going to say try node, and here what I'm going to do, I'm going to say let's define an array. So what I could say, I could say okay, so I need to give a data such a try node, and the name I'm going to give it children, and this is an array, right? Fine. So this is an array, and I'm going to say public try node, and in this constructor I'm going to say, let me write a constructor, not a string. So in this constructor, what I'm going to say, I'm going to say children should be equal to new try node, and here it should be 26 character, and arrays dot fill all children to null initially, right? Once this is done, what I'm going to do, I'm going to say end of word as well, right? So I need to define one more thing, that is boolean. This is going to be end of word, right? And this end of word initially would be what? False, isn't it? We have already discussed this thing. Initially it would be false. Now I'm in a try class, and here what I'm going to do, I'm going to do I'm going to create first of all try node, and this is going to be nothing but root, and which is nothing but, I could say, I'm going to declare in my try constructor. So I'm going to say root is going to be nothing but new try node. Once this is done, I'm going to come in insert function, and insert function what I'm going to do, I'm going to say first of all current. So I'm going to say try node current should be equal to my root, and here I'm going to traverse over this word. So I can say for char ch in words dot to char array, right? Isn't it? We can do like this, to char array, and here what we going to do, we're going to find out the, as we are using array, we need to handle the indexes, right? So index is always in integer. So how to find indexes? So I want to give a to 97, and it is 97, we know that, right? ASCII value of a is 97. So what I can say, a should be start with 0, so and b should have 1, and c should have 2, right? And so on up to z, right? So what I can say, that I can say that int idx should be equal to let's write an integer of ch minus 97, right? Now we can say, like, if current of children, let me write children of this idx is not is equal to null, that means that node does not exist, right? If it does not exist, then we are going to create it, because this is insert function. So we can say current of children on that particular index, you have to just create a new try node. All right, so once we have created it, we are going to move to that particular node, current dot children of that particular idx, and after that we are going to return nothing but, not we are going to return anything, we are going to make the end of word true, right? So current dot end of word is going to be nothing but true. So this was the insert function. I hope you understood this. We have already discussed with C++ Java, and just what we are going to do, we are going to copy and paste this thing, and we are going to say if does not exist, directly return false, isn't it? So if does not exist, so directly return false. Fine. And if it exists, so if we come out from this particular word, we reach to the end of string, check it whether the end of the word is true. Yes, it is true, so return that particular thing, right? If it is false, so it's going to return false. Again, copy and pasting, and here first of all we are going to change word to prefix. I hope it makes sense. And here we are going to say if does not exist, directly return false, because we want a prefix, so return false. And but if exit, we come to reach to the end of string, don't need to check anything, just return true, right? So we can say don't need to check anything, return true, because we also want to get a prefix, or maybe get a full word, right? We don't need to find a complete word existing additionally, right? All right, so we can now try to run this code and see whether we are giving any error or not. And hopefully, I don't think we should get any error, but it's a Java, so we may get, so we have to use a semicolon. All right, so now let's see. And you can see that test case is accepted, right? So let's try to submit this code, and definitely I believe that it should get submitted, right? And yeah, it gets submitted, right? So hopefully we have completed, so we can see implementation Java, C++, Python, and we also cover the logic part, and we have understood the program as well. Guys, if you have still any kind of doubt in any of the section, in any of the part, understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And guys, if you learn something new in this video, if you learn at least one thing in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.